Hi all, and here's another tutorial on rectilinear kinematic motion problems. I've taken one of the hardest problems I could find in previous exams because it encompasses a lot of what we're going to do. And also just on the side here I've put our 4 kinematic formulas that you'd normally have in your formula sheet. Okay. Today I'm going to show you both ways of solving it. On this side I'm going to use the velocity time graph to solve the problem. And on this side, I'll use the equations to solve the problem, so you can see both methods. So as with all engineering problems, the first part of problem solving is to fully understand the problem. So here we have a lift is accelerating upwards from rest. So right away, I know u is going to equal 0 to 3 meters per second, which is the maximum velocity, at a rate of 1.5 meters per second squared. So that's my acceleration. So the first part of the journey, if we just sketch our velocity time graph, we'll do our velocity in meters per second and our time in seconds. It's had an acceleration period. Okay, that's it's gone to 3 meters per second and it had a rate of 1.5 meters per second squared. Okay. It then moves at a constant velocity for 8 seconds, so we don't know what that time is for the first period. So there's section 1. Section 2 we can carry along. We do know that that lasted for 8 seconds, so we'll call that x2, x1. Followed by a deacceleration to rest at 1.2 meters per second squared. So we'll come down, and that was at 1.2 meters per second squared. Again, we don't know what x3 is. Okay. So, first part, draw the velocity time graph for the journey. Well, we've drawn a rough velocity time graph, but we haven't filled in all the information, okay? We have our velocities up the side, 0, but we don't have our times across the bottom. So we need to calculate our times across the bottom. Now, if we choose to use the graph, we know that the acceleration is the gradient of the graph. So the acceleration is the change in velocity over the change in time. Well, we know the acceleration, we know the change of velocity, so we can rearrange this formula to show that our change in time will equal our change in velocity over our acceleration. So if we put the numbers in, we've got 3 divided by 1.5 equals 2 seconds. So we know that that's 2 seconds, and because that was 8 seconds, we now know that at this point it was 10 seconds. Okay, now we go to the final one and we can do the same situation again. We have our change in velocity is still 3. Our acceleration this time is 1.2. So using the same formula, we can have 3 divided by 1.2 equals, I'll jump on the calculator, 3 divided by 1.2 equals 2.5 seconds. So now we know that that's 12.5 seconds. So that's now our velocity time graph complete. We've got our velocities up the side, we have our times along the bottom. Everything else can be calculated from that velocity time graph. I'm just going to do these 2 calculations again on this side using these formulas. So 1, 2, 3. So if we go to section 1, we know that u equals 0, so this is for section 1 only. We know that v equals 3, and we know that a equals 1.5, and we're looking for t. So u, v, a, and t. So we move over to these formulas, and only one of these formulas will have all those 4 components in it, and it's the first one there. So it's v equals u plus a t. We're looking for t, so if we transpose that formula, v minus u divided by a equals t. Put our numbers in, 3 minus 0 divided by 1.5 equals 2 seconds. and that gives us the same, as we'd expect over here, the same. We can do the same again for the second one. So adding the numbers into the second one, it's 3 minus 0 divided by 1.2, and that will equal 2.5 seconds. So we're using the same formula again over here. Right, so let's move on to the questions it's asked us to solve. What is the total distance travelled during the journey? Okay, well, using the velocity time graph, S1, S2, S3, we know that the area of the graph equals the distance travelled. So in this case, we have a triangular shape. So S1, S total will equal S1 plus S2 plus S3. And in this case, S total, S1 is a triangle, so it's a half times the base, which is 2 times 3. S2 is a rectangle, so it's just simply base times height, so that's 3 times 8. And S3 again is a triangle, so at half base times height, so half times 3 times 2.5. And that gives a total answer of, well, half times 2, so that's 3 plus 3 times 8 is 24, plus, I'm going to have to do this part on the calculator, 0.5 times 3 times 2.5 equals 3.75. So our total distance is 3, 24 is 27, 3.75 is 30.75 metres. Now, if we move over to using the formulas and do the same calculation again, S1, to find S1, we have U, we have V, we have A, and we have T. So we need to find a formula that has all these components in it. Now, we did calculate T, so I'd rather not use T, because if we got it wrong in the first equation, it will make us wrong in the second equation. So S, U, V, and A. And we can see it here, V squared equals U squared plus 2AS. So V squared equals U squared plus 2AS. We want to make S the subject, so if we rearrange that formula, we get V squared minus U squared divided by 2A equals S. So let's put section 1, our numbers into it. V is 3, so 3 squared minus, so this is for S1, 3 squared minus 0 squared divided by 2 times, and we're looking for A was 1.5. So 3 squared is 9, minus 0 is still 9, divided by 2 times 3 is 3, 9 divided by 3 is 3 metres. And as we can see, that's the same as what we got down here. Right, so now we'll move on to S2. Again, what do we have? We've got U, which is 3. We have V, which is 3 because it's running at a constant speed. We have our acceleration equals 0. And we have T, which is 8 seconds. Well, in this case, we were given the 8 seconds and we were given the 3, so we can simply use one of the formulas. There it is, S equals a half U plus V T. So S2 equals a half 3 plus 3 times 8. 3 plus 3 is 6, half of 6 is 3, 3 times 8 equals 24 metres. And again, it's the same as what we calculated here using our velocity time graph. So now we'll move on to S3. What do we have for S3? Well, we have U, which is 3, we have V, which is 0, and we have A. So we need to find a formula, and it's the same one we had up here, and we can rearrange it the same way. V squared minus U squared divided by 2A equals S. So if we put our numbers into the equation, it equals 0 squared minus 3 squared divided by 2 times negative 1.2 because it's deaccelerating, so we put the negative in there. So 0 squared minus 3 squared, so that's minus 9. 2 times negative 1.2 gives us negative 2.4. So minus 9 divided by negative 2.4, and I think you'll find that comes out at 3.75. So again, our total distance equals 30.75 meters. Now, the last question asks us to find the average velocity of the journey. Well, it doesn't matter which one we use, because V average will equal our change in distance, so our total distance over our total time. So our total distance is 30.75 meters divided by our total time, which is 12.5 seconds. So that will equal, and we'll rattle that through the calculator, 30.75 divided by 12.5 equals 2.46 meters per second is our average velocity. Done.